Hi, my name's Chermelle Engel. I work at RMIT University with Professor Simon Jones and Associate Professor Corinne Reinke. And what we're working on is detecting fires over Australia using a new source of data information from the Himalaya 8 geostationary satellite operated by the Japan Meteorological Agency. Australia has a long history of fires. This includes the Black Saturday and Black Summer fires of recent history. During such really big fires, and also more routinely, it's important to be able to detect fires as they occur. Most commonly, what we're really hoping for is at the earliest stages, to be able to monitor fires once they're happening on the ground, and also to create a historical record of fires that we can go back and analyse later. Satellite data provides a really useful information set for these purposes. You can see a picture of the full disk that Himalaya 8 scans. It's a geostationary satellite. It scans that disk every 10 minutes. And one of the channels of the satellites is particularly sensitive to the radiation from fires. It's a huge opportunity having access to such information over Australia, but it also presented quite a big challenge, because the Himalaya 8 satellite sits at about 35,800 kilometers away from the Earth while it's scanning the disk. And the information that it provides, each pixel, represents an area of about 2 kilometers by 2 kilometers. And the fire information can be complicated by coincident things that happen, such as clouds passing over by that can block fires, even smoke can block fires. And also they can reflect radiant energy to mimic fires as well. So we had to put a lot of work into creating a robust algorithm that can give as many detections as possible while limiting the amount of false detections due to these complications. The algorithm involved analysing the data both spatially and temporally, and developing statistics that were sensitive to the biogeophysical characteristics of the landscape, the seasons, and the time of day. Here's an example of fire detections from our system that uses a Himalaya 8 sample. And starting the video now, each grey symbol is one of our hotspot detections. On the left, you see the raw visible Himalaya 8 information, and on the right is the channel that's most sensitive to fire. And you can see in the little areas where there's a bright spot in this mid-infrared channel, our symbols fall on the same spot. Although they sometimes are complicated by this heavy smoke that was occurring during the Black Summer fires. And to give a bigger sort of feel for how the fires behaved during Black Summer from a satellite point of view, here is another longer video starting on the 27th of December and running through to the 1st of January with magenta symbols for our detections. And you can just see how complex the fire behaviour was, how complex the weather environment was at the same time. So it was a very difficult task to do, but our system performed quite well given the challenge. So what we have done is we started off with a 12-month historical data set to develop what we could in terms of a robust algorithm to handle Himalaya 8 satellite information. And while we were doing that, we also segued into producing real-time fire detections over New South Wales and Victoria. And we ran from March 2019 to March 2020, covering the Black Summer fires. And we are now currently working on all of Australia fire detection system, which is running today in real time with representatives from each of the states getting our data. And we've done a 12-month, essentially a background to see how that algorithm would have performed if it had been available. And we're showing commission areas of roughly 6% against modus inverse in daytime and nighttime. For more information about our system, please check out our latest publication detailing the historical robust algorithm that we developed, and look out for the new real-time algorithm publication that we're working on currently. Thank you very much.